Okay, so hopefully everyone's back here. I'm starting to record this, so if you're back, that's great. What we're going to do is I'm going to kind of bounce back and forth a little bit between here and Desmos, okay? Um, the first thing we're going to do is talk about what's in the textbook. They refer to even and odd functions. Now everything that we're going to do in the next little bit here is going to be on just the graphs of functions, their properties of their graphs, some of the things, the characteristics that we see. Interesting enough, this comes back at the end when we do polynomials. Towards the end of the course, we'll come back and do some more of this. And I'm going to point out some of the things that students have kind of struggled with in the past. So we'll point those things out also. But even in odd functions, to be honest, I'm not going to test or quiz on this. I'm going to go over it, but it's not something that I'm going to make a huge priority. So I will talk about it because it's in the textbook. An even function, okay, there is a definition for that. And it says that if a function is considered to be even, all right, then here's the, I'm just kind of shortening this out. F of negative x is the same as f of x. So what exactly does that mean? Well, it means if I put a negative values in for x, it would be the same as if I put that same value in, but it was positive. All right, so you're going to get the same thing. What, on a graphical standpoint, what that means is that the graph is going to be symmetric about the y-axis. Yeah, it would. It doesn't have to necessarily be centered on the 0 because you could have this, all right, and it would still work okay. They give an example of that, and we can give you an example too. So anytime that you can take this graph and you can flip it or fold it over that y-axis and it meets up on top of each other, okay, it's an even function. All right, so anytime we have that symmetry about the y-axis, okay, then we say, oh, that is an even function. So that the easiest way to tell that when you're doing some of the problems is to either graph them, just graph them in Desmos and look at it and see if it's symmetric. So that one, for example, the parabola, as Kobe has mentioned, that is symmetric, all right? If you have an equation such as this, so let's do like a little parabola sort of thing here, all right, f of x equals x plus 3. To check to see if it's symmetric using some sort of algebraic idea, we would take this negative x, put that in there, and when I square negative, it's going to change to a positive, and see how these two things are the same. All right, so that makes it even. So you can go about it that way also. All right, you can just stick that negative x in there and see what happens. All right, what happens if we have one that is, say, let's do something like this. Let's do an x cubed plus 3, right? So now if I go f of negative x, right, and I put that in there, it says my internet connection is unstable, so I don't know how that's going to work. Hopefully you guys can hear me and I'm coming across okay. Now what would happen is, since I have a negative and I'm cubing that, so negative and negative make a positive, but then another negative makes it back to negative. And since these things are not the same, then that is not odd, or excuse me, not even. Okay, so, and you can graph it too, right? You could have typed those in Desmos and check to see what x cubed plus 3 looks like and see, hey, is that going to be symmetric? And in fact, if you graph it, it looks something like this. And no, it doesn't work, because if you fold it, right? So if you fold it, this part's gonna come over here, and this part's gonna come over there, and it doesn't work out. All right. So you can look at it either way, graphically or algebraically. All right. So that's even functions. So odd function says this: f of negative x is equal to the negative of f of x. So now they're saying something different. Now this one's a little tougher to figure out symmetry-wise, all right, because it's symmetric about the origin. Okay, so it's symmetric about the origin. So actually, the cubic does work, because if you flip this pink part here about the origin, it comes down this way. It's really hard to see that symmetry. Some people can. It's hard for me to see it, but that's what's happening. So if you have, say, f of x, now let's go with our x cubed plus 3 graph, all right? And you would think, hey, well, would this work? Well, let's try it. So we're going to take f of negative x, which is going to mean I'm going to put a negative in there. Okay. Now a negative x to the third, well, we just talked about that, so we end up with this, all right? But in order for it to be an odd, it has to be the opposite of what the original function is. But you would say, wait a second though, isn't it? Doesn't that work out? Well, not really, because this negative is going to go to the x cubed, but also to the 3, all right? So that doesn't work, because this is a minus 3 and that's a plus 3, so they aren't the same thing. So that means this is not odd. So the only way that it can be odd is if it didn't have that a constant being added to it, right? Or it was an x cubed plus an x. Then that would be okay. Because when we put a negative in there, then everything becomes negative and we're all right. So I would just say to try to graph these a little bit and look at them that way, or you can do them algebraically, but I'm not making this a big priority, because I just don't think even and odd is really all that important in the grand scheme of things. What we're really interested in is increasing and decreasing. So I'm going to put a couple graphs in the chat here for you guys to look at, so everybody gets a look at these in Desmos. All right, so let's put this first one in here. Okay, so there's one of them, and you can type them both. You can type them all in, but I wouldn't have them all on at the same time. So if you click on the little button where the color is, you'll see what I'm talking about, and you'll turn it, that will turn it off. And you only look at one at a time. Okay, so there's the 3 of them. I hope I got them right. It looks like I did. Okay, so I'm going to go type them in while you're doing it. I don't have, oh yeah, okay. Okay, so hopefully you kind of got these typed in, right? And if you click on the colors, you can turn off the graph, but the function still remains. Don't click on the X because then you got to undo it to get it back. So yeah, you want to go ahead and do that. So let's look at the first one. All right, now I want you to tell me what the zeros are. See if you can figure that out from last time. What are the zeros? And you can chat or tell me. Zeros are x-intercepts. We're looking at the first one that I put in there. The x cubed minus 2x squared minus 5x plus 6. That's the one we're looking at. If you look in the chat, you'll see it in there. Good. I see people finding the x-intercepts. Okay, good. So it looks like a lot of you are getting this figured out. Okay, once you type the graph in, remember the x-intercepts, you're just going to tap on them or click on them. If you're using your phone, you're just going to tap right, and it will give them right to you. Okay, so those are your x-intercepts. Now what we're interested in, and here's where I'm going to do some sharing. What we're interested in is, oh yeah, hang on. There we go. What we're interested in is this idea of increasing and decreasing. Okay. Now this is the thing that tends to throw some students off. So I want to make sure that we kind of, you might not get it right away, but you will eventually get it. So if we're going from left to right, because just like in language, you read left to right like a sentence, math is the same way. So you're going to go from left to right. So we're going to start here, and I'm going to go up here. So this graph is increasing. Okay, it is going up. All right, so when we say from way down here to right to this point, right here, this graph is increasing. Okay, increasing. I'm going to write INC there. All right, now down this way, the graph is falling or decreasing to that point. All right, so it's falling or decreasing. So we say this is decreasing. Now, once I reach the bottom of this, I start to go back up. All right, so it's increasing. So in a way, you can think of it kind of as a roller coaster. All right, so you're going up, down, and up. Now, right at these particular points here, okay, you're neither increasing or decreasing. It's sitting flat. All right, so if it's a roller coaster, it's going up, flat, and then falls down rapidly, right? That's what's happening right there, okay? So when I write this, we write it as an interval. So we're going to say from negative infinity. Now, are we talking about x's or y's here? We are talking about x's. So from negative infinity, which is way over here, and if I zoom out enough, that graph will sooner or later get over to that, way over there, past negative 10, right? Past negative 500, way out to negative infinity. So I'm going to go negative infinity, okay? So I'm cruising along this x-axis. This graph is going up to that point. So then I have to click on that point, and it says negative 0.786. You never include the y's. You only talk about the x's. All right, so then I would go like this and say, okay, so to negative 0.786 parentheses. Because remember, right at that particular point, decimals rounds it anyway, but right at that particular point, it's flat, right? There's nothing happening there. You're going up, and then it hits that one particular instant in time, and then it falls. All right, so that's how we write it as an interval. So for the next one, I'm going to go from negative 0.786 to whatever this point is. So I have to go down, click on that point. Oh, it's 2.12. Now I write that 2.12. Okay, notice I'm using parentheses the whole time because it doesn't contain those particular points or those particular numbers because it's flat there, right? So now that I've got increasing, decreasing, now I come back to increasing again. So that is from again, I'm only looking at the x's. I don't care about the y's, right, to positive infinity. Right. So that's how you do intervals of increasing and decreasing. You always go left to right. The graph goes up, down, up. All right? Only look at the x's. Do not look at the y's. All right, so let's try the second one. All right, so I'm going to clear this. All right, and I want you to try the second one. All right, so we're going to click off of the x third, click on to the x fourth, plus 2x cubed plus minus 7x squared minus 20x minus 12. All right, and we want to talk about, first of all, the x-intercepts. All right, so I want you to tell me what those are. Look at those x-intercepts, or those in the chat. All right, see what we get. This is the second one, the x to the fourth. Good. Okay, good. Let's get another person here, throw it in the chat so I know we got people. Great, thank you. All right, so now we're going to talk about intervals of increasing and decreasing again. All right, so I'm going to share this, and I'm going to let you do some too. All right, so let me go to share this. Okay, so here we're starting from this direction, left to right. All right, we're going left to right here. Okay, so I look at this and I go, well, let's see, this graph is falling, right? So as I come over to this part, it starts to fall down. So it's falling down here. All right, so my interval, that would be decreasing, because it's decreasing, is going down. I would write it as negative infinity to negative. Now I need that point, see? So I need to know what that is. Well, that is negative 2. It just happens to be my x-intercept. So right there at negative 2, okay, now it bounces back up. So now we have a increasing situation. So then I have increasing. I think I'll put that over here. Increasing. increasing, I'm trying to get this written here, increasing from -2 to whatever that point is. So I have to go here, click on that, it's -1.35. Why isn't it writing, you little bugger? Oh, there it goes. -1.35. Again, see how we're putting the parentheses because it doesn't include that, right? It doesn't include it. Okay, so now it's increasing. So now we're going to have a decreasing, right? Another decreasing. So I'm putting it over here. So now I need -1.35 to that number, which is -1. Okay, so that's decreasing, decreasing, increasing, decreasing here. Okay, but wait a second, doesn't it go past that? Oh yeah, it does. It goes past that -1. It's going to keep on going, right? So I got to go down and figure out where exactly does it go? Where does it end at? So let's come down to here. All right, so decreasing, let's see if I can get this here. -1.85. I want to make sure people are kind of staying up with me, so if I'm slowing down a little bit here just to give you some time to catch up. And meet it right on this screen, which isn't always the easiest thing to do. There we go. All right, and now, so that's decreasing. Now we're increasing again. Okay, so from 1.85 to positive infinity. Okay, so increasing, decreasing, all right? That's how this is going to work. But you're always using parentheses and always going to the x's. Yeah, those all direction changes. You're kind of seeing the idea, right?
A quick question.
Yeah.
Uh, for the first part, if it's coming, like let's say it's coming from the bottom up to that -2 area, wouldn't it still be negative infinity, or am I thinking of that wrong?
So we're
Or
looking
would that
at
make it?
this one here, this part right here.
No, like that first line. What if that the line that's coming off of the top? What if that line, the blue line? Yeah. What if that was coming from the bottom to that same -2 point? Would it still be with the rise, or would that still be negative infinity to -2, or comma -2?
So let me see if I understand what you're saying. So are you saying what if the graph came like this?
Yeah, yeah, yeah. Exactly.
And then it kept going up to here? So this would be from negative infinity to whatever that point is, which was what, negative
Oh, got it.
1.35?
But it would still just be negative infinity
Yes.
regardless if it's coming from the top or bottom.
Right.
Okay,
Yep.
got it.
Okay. All right, so let's try this now. I'm going to click off of this, click this one back on, stop my share, and let you try it. Let's do that one. So you guys come up with that one, right? Yes, you're only looking at the x values. Well, if you squished it down to the x-axis so that it was just like a horizontal line, there wouldn't be any
Yeah,
increase. There wouldn't be
that's
any
basically what
increasing.
it. Oh yeah, no, but like if you cut the the area. It's just it helps me visualize, just kind of like it from here to here. Now, if you squish that all the way down, what are those x values? And then you can kind of say if that area is increasing or decreasing.
Okay.
Not if it was still the horizontal line, but the horizontal line kind of part kind of helps to visualize what the actual values are.
So you're thinking like drawing lines down to it, kind of?
Yeah,
Yeah, like what we were doing before, yeah, last on Tuesday, I think. Yeah, you can think of it that
yeah.
way. Sure. Yeah, so go ahead and see if we can come up with some increase and decreasing on these. On this, on the last one, right? It's a 2x cubed one, negative 2x cubed. Okay, good. We're getting some good answers here. Yeah, keep going. Work on it a little bit more. Okay, you want to get increasing and decreasing, all right? Oh, good. Okay, so let's review this a little bit here. I was hoping I could annotate without sharing, but I couldn't do it. All right, so we want to increase. So I got people saying, okay, so I'm just going to put over here. So we're going to increase. Actually, let's do decrease first because that's what we're going to get first. All right, so we're going to decrease. Here we're falling, right? We're falling. So we're going to go from negative infinity to negative 2.3. That's what a lot of you got. Okay. Then when you hit that point, we're going to increase. Again, we're going to put that in parentheses. Again, we're only looking at the x's. All right. We're not concerned about the y's. And 1.3. And then back to decrease again. I'll just put it down here, I guess. Well, that's a nasty D there. And so now we're going from 1.3 to positive infinity. All right. So let me just double check that. Here we go. And click and click. Yep. So that's good. Yeah. If you're getting that, that's great because this is what people tend to struggle on. Is this intervals of increasing and decreasing, right? Going left to right using the x coordinates, right? So make sure you're kind of doing that, and we'll practice that obviously. So any questions on the increasing, decreasing stuff?
For the bracketing, is it parentheses for these?
Yeah, because you're right at this particular point right here. That's not increasing or decreasing. It's kind of flat. So if you think of that roller coaster where it kind of hits that bottom, and then at that one particular point, it's sitting like this, and then it starts to go back up again. So you're down, 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 flat, and then going up. That's why we use parentheses.
Thanks.
Yep. Don't use brackets because brackets means you're containing it. Any other good questions? Okay, so the other thing we're going to do, and this is an easy one. So basically what we're going to do is click on these points. And these are called maximum or minimum values. All right. There's two types of maximum and minimum values. There's what we call local and an absolute. So I'm actually going to stop this share and go over to here. There we go. So for our maximum and minimum points, I usually like to use red for axes, just so you know that. Okay, so if I have a graph right here, okay, that point, and this is going this way, and this is going this way, that's called a local max. And in the textbook, it says that a function will have a local maximum if on a certain interval. So let's say we looked from this, I don't know what these numbers are on the x. We're not really too concerned. Maybe it's like -3 to 1. But if somewhere between here, this thing kind of peaks out, then, and there's numbers though on the whole thing that are higher than that. So in other words, this one here is, any point here is higher than this one, then it's called a local maximum. Okay, it's a local maximum. This one is a local minimum, because again, there are points here that are lower than that, so we call that a local minimum. Okay. What somebody's asking me about, why are these points not, what points, Christian, can you tell me which points you're talking about? For the last one. Yeah. You mean, right. Because at this point here, say this point was 4 on the x-axis. Okay, say it was 4 and -12, for example. All right. So when you're talking about decreasing, which is here, when it hits 4, right, it's not decreasing or increasing. It's a maximum point. So it's a turning point. So somebody said something about changing in direction on the increasing and decreasing. That's exactly right. It's a turning point. So it turns from the function going down to the function increasing. That's why you want to use parentheses, because at that particular point, nothing is happening. It's not increasing or decreasing. It's actually neither one. It's not happening. That's why we use parentheses. Okay. Good. So getting back to this. So this is going to be our local maximum and local minimum. All right. However, if we have a graph that looks like this, all right, then at this particular point, there's nothing smaller than that. That graph does not go any further down. We would call that one an absolute minimum. Okay? But this one would be a local minimum. Again, that's because, right, it dips down, okay? It dips down here. So it's a change in direction. It's a turning point, and it's a minimum. But it's only a local minimum. So if we were to say, what if I looked at, come on. Uh-oh. Oh, here we go. If I look at that particular interval only and not the rest of the graph, then I have a minimum at that point. Okay? But because we're looking at the whole graph, then that becomes a local minimum. Now here, we would have a local maximum, right? Because there are hard points here that are higher. Okay? So there's basically two types, local and absolute. So let's go back to our Desmos thing, all right, that we just had. Hopefully you still have those functions in there, right? Let's go back up and turn on that first one, the x cubed minus 2x squared minus 5x plus 6, okay? I want you to tell me what the maximum and minimum points are and if they're local or absolute. You can just abbreviate it as LOC min, LOC max, ABS min, ABS max. All right. So we're looking at the very first one. That was x cubed minus 2x squared minus 5x plus 6. And they are points. Okay. They are not just the x. You should write the whole point. Let's see how we do. We're finding the maximum and minimums, local and absolutes. You can tell me and put it in the chat. You're looking at the x cubed minus 2x squared minus 5x plus 6. So it was the first one I gave you in the thing. Yeah, make sure, so you write it as a point, okay? So make sure that you write it as a point, not just the x. Okay, good. I'm seeing some good stuff here. So let's look at this. So here's my clicked. I clicked on this one. Okay, this would be my local. I haven't used this. No, I don't know. Anyway, this is going to be my local, right? Because There's points that are higher than it over here on this side. So that's a max. But we're going to write this whole thing down here. We're going to write it as a point. You can if you went 0.786 or 0.78 and 8.2, I'm not going to get, I mean, that's fine. You don't have to write all 3 digits out. All right. This one, local minimum. All right. Because there's points lower in it. Okay. All right. Cool. All right. Let's try this now. Okay. So stop and sharing. All right. Now you're going to do the x to the 4th one. Okay. So x to the 4th plus 2x cubed minus 7x squared minus 20x minus 12. Give me that one. Maximum, minimums, local, absolute. Okay, we're getting some good answers here. Just make sure that you say what it is. Is it absolute? Is it local? You know, which one is it? You know, absolute max is negative infinity, negative infinity. I don't know. That might be like an instructor sort of thing or preference there. I usually say it doesn't have an absolute max. Okay, rather than saying infinity, infinity. So I don't know. I've seen students say that. I'm not sure where that's coming from, but I'm not exactly sure how proper that is, I guess. I'm not, because it doesn't really have a max, right? Oh. Well, you're not the only ones that ever made that up, because I've seen that before. So, yeah. It looks like people are doing a good job here. Max and minimums doesn't cause as many issues as the intervals of increasing and decreasing, because you click on it, you kind of got a feeling for it, right? If it bottoms out, that's a min. If it tops out, that's a max. And then your absolute, it makes sense, right? It's the absolute bottom or absolute top. Okay, sweet. So that's a lot of what is in section 1.3, this is, I think. They do one other thing here. Oh, I know. I want to point something out. Hang on. Let's go back to, I want to show this to you right here. Okay. I want to look at this graph, because you'll have some like this. All right. We have to be careful here, because in this case, here we have, let me annotate this. I'm circling this bright pink here. What is this one right here? Yeah, absolute min, right. That's an absolute min, okay. What about this one right here? What is that? That's a local max. Very good. What is this one? An absolute max. What is this one? Okay, see, that's the tricky part. Because locals have to be in an interval, that one does not count as either. All right, obviously there's a higher point than 3, so it's not absolute, but it's also not a local because it is a starting point. Okay, so the graph actually starts there, or ends there, I guess you would say. So neither one of these points are local max or mins. They are not, because there's no interval that they are in. So there has to be, you can't just say this point is an interval, because it's not. Remember, an interval has to be between like two numbers. So it has to be between here and here on the graph, and then that is a local, all right? But these endpoints are not. So be careful with that. Make sure you understand that those are not considered to be maxes or mins. Okay. The other thing that they talk about, and then we'll have to make some adjustments here. What we're going to do is they have a graph. I'm just going to pick, I think I'm just going to pick a parabola for example here. They talk about what is I want to make sure I get this correct. The average rate of change. And here's how they define that. They say what you're going to do is you're going to find the difference. This triangle means difference in the y's. So you're going to take a function.
Really quickly, Mr. Patterson.
You can't see, can you?
See your screen. Yeah.
Yeah. You're right. Okay, so the average rate of change here, we have change in y over change in x. So what they're going to do is they're going to take this parabola here. I don't know why I'm not getting. There we go. And right now this doesn't make a whole lot of sense. But here we have a parabola. So I'm going to put a point right here. All right, and we're going to call that x point, say B. And then I'm going to call the y point f of B, so whatever the heck that is. And I'll give you some numbers so you'll see. Then we're going to call this one A, and we're going to call this one f of A. Come on, write for me here. There we go. And I'm going to draw a line through it. Okay. So all we're doing is finding the slope of that line. So you're just taking the rise over the run. So we're looking at the differences in the y coordinates over the differences in the x coordinates. And that's what they talk about in the rate of change. Now what this is doing is it takes, if we move these points closer together, then what we're getting is a slope of a line. And at a particular, if you move them closer together, you're getting it at a particular point. And that's a big idea in calculus. So those of you that are moving on to your calculus courses, you'll be doing a lot of that. Okay, so they're just kind of introducing it. So if we have, say, I'll just draw a little parabola and I'll give it an equation. Let me go with like 2x squared minus 4. All right. So I'm going to check and see, well, can you tell me what that is at 1? So I'm going to go here, and the delta represents minus. That's change. The little delta represents change. So what I'm going to do is I'm going to put 1 into this guy here. So that would be 1 squared times 2 is 2, minus 2 is negative 2. So right here, I have 1 and negative 2. All right, now I'm going to go. Is there a question? Now I'm going to go to 3. So I'm going to put 3 in here for x. So that's going to be 3 squared, which is 9, times 2 is 18, minus 4 is 14. So then if I draw a line through those points, I can find the average rate of change by taking the change in the y's. So that would be 14 plus 2, because it's minus a negative 2, over 3 minus 1, and that would be 16 over 2, or 8. All right, so the slope of that line is basically 8. Now again, this is one of those things that I'm not going to test or quiz you on, all right, but it is some of the assignments in the book there. Okay, there's some questions on that. Not very many. I don't even know how many I actually gave. I don't think I gave very many of those. I'm looking it up right now. 65 through 67. No, I don't think I did. Actually, I don't think that I did. If I did, there wasn't very many of them. Oh yeah, there's just a couple of them. Okay. So basically what we got through is we did the Desmo stuff, which gives you page 64 and page 77. We did not get to 1.4, which is fine because we can do that hopefully on Tuesday when I hopefully have internet service. So I will just make sure that we make an announcement that we're not doing page 89, that page 89 is not due on Tuesday. Okay, so all we're going to work on is 56, 61, 64, or 56, 63, 64, and 77. I will go back into the assignments part and change 89 to be due on the 12th instead. All right, so I got to scoot on out of here. If you have any questions on anything, feel free to email me. I will try to get to you. I'm going to be a little bit not, let's see, like Saturday, I can probably get to you a little bit during the evening time if you need to contact me about stuff. And then hopefully a little bit on Sunday. I might be in trouble Sunday because I don't know if I have anything. But anyhow, we'll work together on this next couple of weeks. I appreciate your patience. And that's right. One more time, we are not doing page 89. Okay. Yep. And I will go into making that announcement. I will also make sure I take that out of the Desmos thing that's due. Okay. So, you guys have a great 4th of July, and I hope to see you on, no problem. I hope to see you on, or at least hear from you on Tuesday. All right. So, great. Thank you. We'll see you then. Thank you, you bet.
Thanks. Have a good day.
Hey, you too.